one jet was asked to do the impossible: fight like a raptor, slip past radar, share a battlefield sixth sense with its wingmen, and then drop onto a ship like a helicopter at the push of a button. Meet the F-35B, the stealth fighter built to replace a fleet of airplanes with one audacious machine. But to make that promise real, engineers had to embrace trade-offs that still spark debate today. The story of the F-35B begins not with the plane itself, but with an ambition that bordered on impossible. For decades, the US and its allies operated multiple aircraft for different missions: stealth bombers, agile dogfighters, and short takeoff jets that could land on cramped naval decks. Each plane did one job well, but none could do it all. The dream was simple on paper, but almost absurd in practice. Build one fighter that could replace them all. A jet that could fly supersonic like the F-16, disappear from radar like the F-117, and land vertically like the Harrier. All in a single frame. Video transcript. But every engineer knew this demand came with brutal trade-offs. The laws of physics punished versatility. Stealth shapes often sacrificed agility. Vertical landing systems weighed down airframes. And yet, Lockheed Martin promised they could combine it all. The world's first true jack-of-all-trades stealth fighter was set in motion. What nobody knew then was just how costly, controversial, and complicated this dream would become. What truly set the F-35B apart was its almost science fiction ability: vertical takeoff and landing. With the push of a button, the jet could shift from roaring forward like a supersonic fighter to hovering in place, dropping gently onto the deck of a ship far too small for traditional jets. At the heart of this feat was a massive vertical turbofan, hidden inside the plane's body, paired with a swiveling exhaust nozzle that redirected thrust downward. Video transcript. Together, they gave the F-35B the agility of a helicopter while keeping the speed of a stealth fighter. For the US Marines, this changed everything. Suddenly, amphibious assault ships, never designed to host advanced fighters, could launch some of the world's most lethal jets. It was a tactical revolution, air superiority from vessels once limited to helicopters. But this miracle came at a cost. Designing a stealth jet that could also stand on its tail and land vertically demanded extreme compromises in structure, weight, and reliability. Many inside the Pentagon doubted the system would ever work in combat. Yet the engineers pressed on, convinced that this hidden superpower would redefine naval warfare. When people hear stealth, they imagine an invisible aircraft. But the truth is more subtle. The F-35B doesn't vanish. It delays detection. Its design makes enemy radar signals scatter or fade, buying pilots precious minutes to see the enemy first, and strike before being seen. Video transcript. This wasn't new. Earlier stealth legends like the F-117 and the B-2 Spirit had already proven radar evasion could change the battlefield. But they paid the price in maneuverability and versatility. The F-35B's challenge was combining that stealth with the agility of a frontline fighter. To do that, its engineers reshaped every inch of the plane. Angled edges, radar-absorbing materials, and carefully hidden engine intakes all worked together to minimize reflections. Even its vertical landing system was tucked inside, designed not to betray its position to enemy radar. Yet the compromises never went away. Stealth demanded smooth surfaces, while fighter performance demanded large control surfaces. Each design choice was a balancing act between invisibility and agility. What made the F-35B different was how it layered stealth with intelligence. Its sensors didn't just hide, it thought. The jet was built to gather battlefield data, fuse it into a single picture, and feed it directly to the pilot's visor, giving an awareness edge no enemy could match. The F-35B isn't just a stealth jet, it's a flying network. At the core of its design is sensor fusion, a system that takes streams of radar, infrared, and electronic data, merges them instantly, and delivers it directly onto the pilot's helmet visor, video transcript. That visor is unlike anything before it. Instead of looking at old-school cockpit screens, The pilot sees a live 360-degree digital battlefield. Enemies appear as glowing icons, threats are highlighted in real time, and targets can be tracked through clouds or darkness. It's as if the pilot has a sixth sense. Even more powerful, this data doesn't stay inside one cockpit. Every F-35 shares what it sees with every other F-35 nearby, creating a hive mind of fighters. If one jet detects a threat, they all see it. If one locks onto a target, the others can engage instantly. In combat, this means a formation of F-35Bs doesn't just fight as individual planes. It fights as a single organism. For adversaries, this is a nightmare. Facing one stealth jet is hard enough. Facing a swarm that acts with a collective brain is almost impossible. And this wasn't just theory. The US military bet heavily on the F-35's hive mind to dominate tomorrow's wars. But the question remained, could this advanced brain survive the brutal demands of real combat? For all its brilliance, the F-35B was built on painful compromises. Every cutting-edge feature, stealth shaping, vertical landing, sensor fusion, came at a cost. Engineers wrestled with a puzzle that sometimes seemed unsolvable. Take stealth, for example. To reduce radar reflections, you want smooth, angled surfaces. But fighters need big, movable control surfaces for agility. The F-35's designers had to carefully angle its tail and wings to avoid radar corner reflectors, while still giving the jet the maneuverability of a frontline dogfighter video transcript. Air intakes were another battle. Mount them on top, like the B-2, and you reduce radar signature, but starve the engine during sharp maneuvers. Place them beneath, like on the F-16, and you risk huge radar reflections. The solution? Twin intakes along the fuselage, with clever bumps and diverters to control airflow. Every curve was a compromise between survival and performance. And then there was the elephant in the room: cost. By the time the F-35 program matured, it had become the most expensive weapons project in human history, with estimates soaring past $1.7 trillion over its lifetime. Critics argued the US had built a plane too advanced, too complicated, and too expensive to truly rely on. The result was a paradox: a fighter that promised everything, but carried a price tag and set of limitations that fueled endless controversy. On paper, the F-35B looked unstoppable. But war isn't fought on paper. It's fought in the sky, against skilled adversaries, in situations no simulation can fully predict. So how did the jack-of-all-trades jet hold up when tested? In exercises, the F-35B proved devastating in its first look, first shot, first kill roll. Thanks to its stealth and sensor fusion, pilots could see enemy aircraft long before being seen themselves. In simulated dogfights, F-35s routinely killed opponents before the other side even knew they were there. Commanders described it as cheating, a kind of battlefield invisibility cloak video transcript. But these victories came with caveats. The F-35B isn't the most agile jet in a close-range fight. It was never meant to outturn an F-16 in a knife-edge dogfight. Its vertical landing system adds weight, limiting payload and fuel capacity. Critics argue that in drawn-out battles, these limitations could become fatal. Even its software dependency raised alarms. The jet's brilliance relies on millions of lines of code. Glitches or cyber vulnerabilities could cripple entire fleets. To some, the F-35B feels less like a fighter and more like a flying supercomputer, powerful but fragile if the wrong system fails. Still, the results were undeniable. In controlled combat trials, the F-35B's kill ratio dwarfed older fighters. For allies who flew against it, the message was clear. This was a new era of air power. The F-35B was never just an American project. It became a global gamble. More than a dozen allied nations signed on, investing billions into a program that promised not just a fighter jet, but entry into an exclusive security club. Buying the F-35 wasn't only about air power, it was about deepening military ties with the United States. For countries like the UK, Italy, and Japan, the F-35B offered something unique: a stealth fighter that could operate from smaller carriers and assault ships, bringing cutting-edge air dominance to seas once out of reach. It reshaped naval strategy around the world, but with partnership came controversy. Costs ballooned, delays piled up, and technical problems made headlines. Politicians were forced to defend a program that critics called a money pit. Some nations questioned whether they had bought into a miracle machine, or a trap that would lock their militaries into endless dependence on US upgrades and software support. Still, allies kept buying. Why? Because for all its flaws, no other plane promised the same combination of stealth, versatility, and future-proof technology. For many governments, walking away from the F-35 wasn't just expensive, it was unthinkable. In the end, the F-35B wasn't just a jet. It became a geopolitical contract, a weapon that tied the fate of entire militaries to America's technological gamble.